Right. Welcome to this explainer. We are embarking on a genuinely mind-expanding journey today. You see, on scales way beyond what we can normally perceive, the cosmos is hiding these wondrous landscapes and exquisite structures. And at the absolute largest stretches of the universe, the laws of physics have some utterly bizarre consequences that flip everything we thought we knew on its head. I'm absolutely thrilled to guide you through this as we look inside the gigantic universe and explore impossible scales. So here is our flight plan for today. We'll start close to home, shattering the solar scale, then move on to our cosmic life raft. From there, we'll look at measuring islands of stars, the dark galactic glue, rivers of flowing galaxies, and finally, breaking the universe's rules. Let's get right into it. Okay, let's dive into part one, shattering the solar scale. For centuries, when humanity tried to conceptualize the heavens, we built these beautiful mechanical models of our solar system known as orreries. But to actually grasp the true scale of our immediate neighborhood, we really need to shatter those preconceived notions. So, imagine for just a second that we shrank the Earth down roughly 60 million times, making it the exact size of a standard football. On that scale, where's the sun and how big is it? Well, it's over 100 times larger than our football. You could literally fit a million Earths inside it. And it wouldn't just be sitting across the room. It would be 2.5 kilometers away. Suddenly, the sheer emptiness of space becomes shockingly clear, doesn't it? Because space is so astonishingly vast, using kilometers straight away becomes wildly impractical. So, astronomers had to invent a grand new measuring stick, the astronomical unit, or AU. 1 AU is that 150 million kilometer gap between the Earth and the Sun. To put that into perspective, our outermost planet, Neptune, is orbiting in the freezing dark an incredible 30 astronomical units away. Section 2. Our cosmic life raft. Now, you might think Neptune is the end of the line, but if we transition much further out to about 120 AU, we hit a giant, mysterious structure shielding our entire solar system. We tend to think of space as a totally empty vacuum, but actually it acts a lot more like a fluid. Between the stars lies the interstellar medium, which is this diffuse soup of tiny amounts of dust, gas, and plasma. At the same time, our sun's twisting, intensely powerful magnetic field creates a solar wind that flows constantly outward. At 120 AU, that solar wind violently crashes into the interstellar medium, creating an incredibly turbulent magnetic boundary. I absolutely love this analogy. The heliosphere acts just like the hull of a boat. Because the interstellar medium is made of flowing gases like hydrogen and helium, the heliosphere pushes through the fluid of space and actually creates a massive bow wave. This magnetic bubble is crucial to our survival, as it deflects and scatters cataclysmic radiation from exploding supernovas, quite literally acting as our cosmic life raft. To unlock the mysterious workings of this life raft, we really need to understand the sun's magnetic field, and that is exactly what the European Space Agency's Solar Orbiter mission is doing right now. Featuring instruments built by a brilliant team from Imperial College London, this probe braves blistering 500 degrees Celsius heat just to measure that magnetic field. Every single day, it sends the team an email from space containing this invaluable data. It's a total triumph of human engineering. Moving on to Section 3, Measuring Islands of Stars. Leaving the relative warmth of our solar system behind, we pass a vast sphere of icy objects called the Oort cloud, which stretches up to 3 entire light years across, by the way, and we enter the wider Milky Way. It's staggering to realize that just over a century ago, most astronomers firmly believed our galaxy was the entire universe. The person who changed that forever was Henrietta Swan Leavitt. Working as a human computer at Harvard Observatory, she painstakingly analyzed photographic plates of 1,777 pulsing stars known as Septi variables. Through her sheer dedication, she cracked a massive cosmic code. She realized there was a strict mathematical link between a star's intrinsic brightness and how quickly it pulses. By comparing its true brightness to how dim it appears to us on Earth, she essentially gave us a way to measure the deep cosmos. So, Leavitt provided the very ruler we needed to measure the universe. Fast forward to 1923. Edwin Hubble used her brilliant method on a fuzzy patch in the sky known back then as the Andromeda Nebula. He proved it wasn't a nearby gas cloud at all, but an entirely independent galaxy situated a staggering 2.5 million light-years away. In one stroke, the universe became unimaginably larger. Section 4. The Dark Galactic Glue. As we pull back to view the entire 100,000 light-year span of our Milky Way galaxy, we encounter a massive mystery uncovered by the brilliant astronomer Vera Rubin. When she studied galactic rotation, the math simply didn't work out. The visible matter, all the stars, gas, and dust we can actually see, didn't provide nearly enough gravitational glue to keep spinning galaxies from just flying apart in all directions. Rubin concluded that an astonishing 85% of all matter in the universe must be completely invisible to us. We call this mysterious scaffolding dark matter. But gravity holds other dark secrets at the centers of these galactic islands. Using X-ray telescopes to peer through the cosmic dust, astronomers detected massive energy shock waves rippling out through the interstellar gas of a distant galaxy. These ripples are actually sound waves. They correspond to a B-flat note, but get this, it is 54 octaves below human hearing. To play a note that phenomenally low, you would literally need an organ the size of an entire galaxy. So what on Earth is generating these colossal musical outbursts? Supermassive black holes. As matter swirls inward, just like water spiraling down a kitchen plug hole, it forms a massive accretion disk. The resulting friction causes an astonishing buildup of heat, reaching hundreds of thousands of degrees. The black hole then ejects jets of high-energy particles, blowing material outward and fundamentally shaping how the entire galaxy evolves around it. Section 5. Rivers of Flowing Galaxies. With an estimated 2 trillion galaxies out there in the observable universe, you have to ask, do they travel as lone wanderers in the dark, or do they move together? Well, astronomers use the Doppler effect to find out. Just like the pitch of a passing siren changes as it drives by, light waves stretch and compress depending on movement. If a galaxy is moving away from us, its light stretches and appears redshifted. If it's moving toward us, the light compresses and is blue-shifted. When looking at our neighbor Andromeda, astronomers noticed a tiny shift toward the blue. Yep, Andromeda is locked onto a collision course with us, racing our way at a terrifying 300 kilometers per second. By mapping out all these shifts, we realize galaxies definitely don't float aimlessly. They are fiercely pulled by gravity into this vast hierarchy. Galaxies fall into local groups of up to 50, which plunge into larger galaxy clusters containing thousands, which in turn flow into unimaginable superclusters containing millions of galaxies. It is exactly like raindrops flowing into streams, and streams cascading into massive rivers. Back in 2014, a dynamic cosmographer named Helen Courtois and her team created a breathtaking 3D map of our very own galactic river system. They discovered that our Milky Way, along with 100,000 other galaxies, are all flowing together toward a mysterious gravitational anomaly we call the Great Attractor. They named our massive home supercluster Laniakea, a beautiful Hawaiian term meaning immense heaven. And immense it absolutely is, stretching across 500 million light-years of space. Section 6. Breaking the Universe's Rules. We've now arrived at the absolute largest observable scales on our cosmic journey, where our recent findings actually threaten to break the foundations of modern physics. One of the absolute pillars of cosmology is the cosmological principle. It states that after the Big Bang, matter was scattered evenly. So, if you zoom out far enough, past the galaxies and superclusters, the universe should look uniform and featureless, kind of like a smooth sheet of sandpaper. Based on our current understanding of gravity, structures larger than 1.2 billion light-years simply shouldn't be able to form. But then, a PhD student named Alexia Lopez was mapping distant matter using quasars, these immensely bright galactic centers that basically act like cosmic spotlights. In a completely serendipitous discovery, she found a pattern of galaxies blocking the quasar light. When plotted out, they formed an incomprehensibly massive structure called the Giant Arc. It is over 3 billion light-years wide. According to the rules of our universe, it simply should not exist. The implications of the Giant Arc and other superstructures discovered recently carry tremendous gravitas. If the cosmological principle is wrong, then our entire timeline of how the universe formed after the Big Bang is fundamentally flawed. As Alexa elegantly put it, pulling away the cosmological principle is kind of like taking the bottom piece of a Jenga puzzle out. The whole tower of our cosmological understanding collapses. And that leaves us here, staring into the great, awe-inspiring dark. From those tiny mechanical orreries of centuries past to superstructures billions of light-years across. Every single time we build a better tool to see the cosmos, the universe astounds us with entirely new rules. So I'll leave you with this provocative thought. If the foundational principle of modern cosmology is wrong, What else are we missing in the immensity of heaven? Keep looking up, keep asking questions, and I'll catch you in the next explainer.